favorite superhero? Superman? Superwoman? Well, mine are superconductors. Well, what is that, and what are its superpowers? Superconductors have some groundbreaking properties, such as zero electrical resistance and the Meissner effect, which essentially is the expulsion of all magnetic fields, kind of working like a force field. This essentially allows for levitation and the production of maglev trains. But like most superheroes, superconductors are ordinary-looking materials most of the time, until they reach a critical temperature, at which all of a sudden they transform into the superconducting state and display their superpowers. If we could harness these superpowers at room temperature, we could make all kinds of transformative technologies. For example, have you ever wondered why we need to recharge our devices? Well, part of it is due to electrical resistance, or the diminishing of electrical current over time. But superconductors have zero electrical resistance, which means that their current never dies. Let's think of it like a dance party. In a normal conductor, electrons are at a rave, individually dancing and colliding with each other, eventually having to stop. But in a superconductor, the electrons find a partner, and together they can slow dance in perfect coordination and continue to go on forever. Theoretically, we have an infinitely lasting current, and thereby an infinitely lasting battery, allowing us to never have to recharge our devices again. Outside of our devices, superconductors are applicable in renewable energy through the creation of nuclear fusion plants. The most popular technique for nuclear fusion is magnetic confinement, which requires a strong magnetic field to confine plasma. Superconductors are able to create the extreme magnetic field needed for this technique. Nuclear fusion could supply us with a sustainable renewable energy source, changing the trajectory of our future. Somehow, superconductors can still be cooler than that. This is a Josephson junction, which essentially is two superconducting materials with an insulating barrier in between. However, the superconducting properties are maintained across this barrier. Coupled with superconducting circuits, these Josephson junctions could allow us to create artificial quantum bits, and gaining greater control over qubits would revolutionize quantum computing. So, superconductors are pretty cool, but with more research, we could get them to superconduct at higher temperatures, and one day bring the dream of a room temperature superconductor to reality. So the next time you think super, don't forget about the super properties of superconductors.